Hare Krishna. Hope you are doing well. Let's get started with some more adventurous questions in IIT Jam PS, IIT Jam numerical. So, this is a question about optimization because it's asking to minimize distance, and we will see it involves circles and a little bit of trigonometry as well. So, let's get started. Now, the point over here to build intuition is that you have a two-dimensional setup, but there is scope to reduce it into one dimension. How? We know that a circle, just assume it's a very beautiful, perfect circle. A circle, the points in the circle can be characterized just by the theta parameter and the radius parameter, right? So the point is r cos theta and r sin theta, where theta can go from 0 to 2 pi. So this essentially transforms our setup from two dimension to one dimension because the radius is already known. It is the square root of 12. And when we do that, we know that we have to compute the distance of the point, which is now essentially this point where r is 2 root 3 from the given point. So it simplifies. And we also know that we can take the square of the distance. The distance over here is taken as a function. We can take the square of it. Still, the minimization would remain the point of minimization would remain the same. Now, a point of error that can happen over here is we can maybe go in the direction of derivatives. Derivatives are not wrong, but when you differentiate the function and see that you are getting a certain derivative which gets complex to deal with. So, for instance, over here, the motivation would have been to see whether the derivative is greater than 0, less than 0, or equal to 0 at some point. But if this is the case, if this is equal to 0, then it would be something like tan theta equals to 2, and that's not a very standard uh, value. So it gets difficult. So when you see that the derivative is getting complex or the computation in general is getting complex, maybe the direction is not fast or not right. And indeed, when we simplify the function, we see it is this. And this is a constant minus this thing. Now our objective is to minimize this, which would be the same as maximizing this, because the greater this quantity, the greater it will be, subtracted, because it's a minus sign over here. So that's why. And the neat trick over here is to convert the two trigonometric functions into one. And it's a very nice approach. I would want you guys to be mindful over here, more attentive over here. So what we essentially do is we look at the coefficients multiplied with the two trigonometric identities, and then we scale them by the square root of their sum of squares. The reason is this thing and this thing would now be treated as sine and cos themselves. How? There is a formula. Let's go to theory. So essentially we have a setup like this where we can, this is a very standard formula. Sine A cos B plus cos A sine B equals to sine A plus B. So when we convert this into one trigonometric identity, which is a sine identity, we know that the maximum value that sine identity can take is 1. And on the basis of that, we come and go for our theta. Note, although we introduced another angle over here called sine phi. Our main parameter of interest is theta. So we want to get the theta for which this is maximum, and this is this value. And we have the theta, and b minus a is nothing but 2 root 3 sine theta minus 2 root 3 cos theta, and which is the coordinate difference between the coordinates of the point. And we get this when you, thankfully you'll be given a calculator, online calculator. So using that you would see that this value comes close to 1.55, which is the answer. So that's it. Hare Krishna. And going beyond the syllabus now. So up till now we saw that Arjun was stressed and Krishna started speaking, and the parallels we drew for the student about to give the exam, competitive exam, is that the student also feels stress, and it's like an army of expectations tied to the questions that the student sees. And just in the last video, we left on a cliffhanger that had Arjun surrendering and Krishna was going to speak. So this is what Krishna is now actually speaking, not as a friend but as a kind of guru or wise counselor. That while speaking nice words, you are not being wise actually. And that's quite relatable because for whatever reason, we also tend to use a lot of words to describe our pain sometimes, but without actually completely understanding the context of our own pain and why we feel it. So we create a jargon of word jugglery, sometimes deliberately to avoid discussing about the matter, sometimes unconsciously. So Krishna is getting right to it that the wise don't lament for anything. Because you are lamenting, you are not wise. So it's the beginning of wisdom. Let's see what will happen next. Take care. Hare Krishna.